Today we're going to talk about Ohm's law, and I'm going to do some calculations with some components on a series circuit and a parallel circuit, just to make sure that you have a good understanding on how it works. We studied that earlier this week in my grade 9 science class, and I figured that I will show you information about that. So first of all, what is the Ohm's law? The Ohm's law is the relationship between the voltage or the potential difference, the resistance of different parts in a circuit, and the current, so the number of electrons going through a circuit. So the reason why this is interesting is that depending on where we are on the circuit, we can calculate information about it. So let's see what we've got. I have here a simple circuit with here, let's see, I'm going to do another one. I'm going to say this is 6 volt. We have here an ammeter. Oh, look at this. I have two. It's always interesting. I'm going to say I have 0.2 amps, and I have 2 bulbs. I have 2 bulbs that are different. The resistance on this bulb is 10 ohm. The resistance on this bulb is 20 ohm. Remind you that the current in the circuit is how many electrons are going through a circuit at one time. We have the potential difference, the energy of the electrons going through the circuit, and we have here the resistance. It's how much the electrons are slowed down, so there's a transformation from the energy of the electrons to create something new. And here I have 2 bulbs. I'm going to put a card probably up here from a video I did last week with the symbols that we use to create symbol that we use to create sketches like this of circuits. It might be helpful. So I'm going to put the card right here. So let's do some calculations right now. So first of all, we know some information. We know the voltage here at the source. We know what is the current. And here what we don't know the voltage, the potential difference at this bulb. And we don't know the potential difference at this second bulb. So let's see if we can do some calculations together. So first of all, we have to look at the information we've got. Here we know that the total potential difference is 6 volt, but we don't know what it is at this bulb, number 1. So I'm going to put here a question mark. I know that the resistance at the bulb is 10 ohms, there you go. And the current is the same everywhere because the electrons are following one path only, and it is 0.2 amps. If I'm looking for the voltage here, I have, I have the voltage, which is R times I like this. We will just substitute the values that we have. So we have 10 ohms times 0.2 amps, and that gives us right here 2 volt like this. So the voltage at the first bulb is 2 volts. 2 volts like this. Now, as you can see, the total potential difference is 6 volt, and 2 goes to this one here. So we would not have to do any calculations to figure out what the voltage of the second bulb is. The reason being is that the energy of the electrons going here at 6 volt, they drop 2 here. That means that they have 4 volts left. So here we know, using the Kirchhoff's law, that it is 4 volt. But let's see if someone would like to do the calculations. So let's see what we've got. The voltage at the second bulb, we don't know. We know that the resistance at the second bulb is 20 ohms. And we know that the current at the second bulb is 0.2 amps right here. So that means that the voltage at the second bulb is what? It's 20 ohms times 0.2 amps, and we have 4 volts like this. So we did the calculation. We are right for this one right here. Now, when you're using the Ohm's law, you have to look at the information you have, and in order to know what you can use the formula about. So here I had the resistance and I had the amps. If it happens that you have the current and you have the voltage, you can figure out what the resistance are at each of the bulbs here. The idea here is that you're looking for the 3 pieces of information that each of those loads would have. If you have 2, you can find the third one by using the Ohm's law, which is V equals R times I. So let's see if I can do another example, but this time using a parallel circuit. My second example is about a parallel circuit. So here we're going to use the Ohm's law to look for the missing information. So first of all, we know that the battery here has 6 volts. We have a parallel circuit. Each of these branches have 0.3 amps here and 0.6 amp here. So that means that the 2 bulbs here have 2 different resistance. So let's see what we can do. We also know that we have an overall current that is here, knowing that when electrons are going through, so this is negative and this is positive, when the electrons are going through this one, they are divided in 2 different paths before they're going back to the source. Now, knowing that we have 0.3 amps going this way and 0.6 going this way, so when they all meet here to go to the source, we would have to add both of them. So here we would have 0.9 amps like this. So that's the first thing. Now, the next thing we don't know, do we know the voltage on the bulb right here? Because we have a parallel circuit, the voltage going through the source here will be the same as the voltage here will be the same as the voltage here, because each electrons going this way would have 6 volts to go here and 6 volts to go there. So the one thing we don't know what the resistance is for each of the bulbs. So let's do some calculation. We're going to call this bulb number 1, this bulb number 2. So here, if I have bulb number 1, we have voltage 1. We know is 6 volt. We know here that the amps is, here we have 0.3 amp here for the current, like this. So here we're looking for the resistance. Now, since I have V equals R times I, if you multiply by I here, you will divide on the other side. So here we have the resistance is the voltage on bulb number 1 over the current of bulb number 1. So the voltage here is 6 V over the current 3 amps like this. So let's see, we have a resistance here of the one which is 20 ohm like this. So 20 times this one will give 6 volt. Perfect. So here I was able to measure some information, a voltmeter for the here, the potential difference, a voltmeter for potential difference here. I have an ammeter that I can measure here, here, and here. And through calculations, I was able to find the resistance. And the resistance of the first bulb is here, 20 ohm. I know that if you have a multimeter, you can actually use the resistance function to find, and therefore it's called the ohm meter, to find the resistance of a circuit. But sometimes if you don't have those handy, you can use the Ohm's law to figure out the missing information. So let's see if we can find the information about the second bulb. We know that we have the voltage on the second bulb, which is also 6 volt. We have here the current of the second bulb, which is 0.6 amp. So let's see if I can put it this way, amp like this. And we're looking for the resistance of the second bulb. So here, as earlier, V over I equals R. So we have 6 volt over 0.6 amps, and that will give me this ohm, 10 ohms like this. Perfect. So we have here the resistance of the second bulb at 10 ohm. We were able to calculate that. So here the resistance of 2 is 10 ohm like this. It's going well. We were able to find the information. Now, interestingly enough, finding the overall resistance of a circuit can be a tricky thing when we have parallel circuit, because using the Kirchhoff's law, the reciprocal of the total resistance equals the sum of the reciprocal of all the other resistance. However, my trick here is interesting. If I have here the total voltage at 6 volts, so VT, which is at 6 volts, but I also know that the total current is 0.9 amps like this, I can certainly find the overall resistance. So let's see. We'll do the same thing as earlier. The overall resistance equals the total voltage over the total current. And here you can see there, perfect. We have 6 volt here and we have 0.9 amp. I'm going to need a quick calculator because my mind is not cooperating to do something complicated such as this calculation right now. If you can do it by in your mind, please, you can write it down. So I have here, so let's see, 6 divided by 0.9, it gives me 6.67 ohm like this. As you can see here, for the resistance, we do not add the resistance per se. We need the calculations a bit trickier. However, if you don't want to use the whole formula, keep in mind that if you can figure out the overall current by reflecting on your circuit, and you know the overall source, the value of at the source, you can certainly find the overall resistance. And I think this is quite exciting. So this gives you an example on how we can use the Ohm's law to find specific examples and specific information that we are missing. On this, if you have any questions, please put them in the comments below. If you have any clarification questions because you want to go a bit further on this discussion, put your question in the comments. I'm here to help you. So I'm going to put here a link to another video that you will enjoy, and I'll see you there in a moment.